Yeah. When I talk about the backend, the data warehouse and ETL processing and the large databases to store huge magnitudes like Teradata and Netezza, and purchasing the storage from SAN, all these things are making the data storage and processing is too expensive. And we need an alternative. That is one and only Hadoop. Of course, this is not so simple as we talked about because we can't change all your infra overnight. So in order to change this, there should be several drawbacks in the existing storage and processing methodologies. Because the simple word like Hadoop, we can't change your infra, so there must be several drawbacks in the existing data storage and data processing methodologies. Let me just share what are all the drawbacks. And consider you have a bank account which is open somewhere around 2000. After 13 years, in 2014, you approach the bank and you ask them for past 3 months bank statements, which will get hardly a couple of minutes or at least half an hour of time. Consider the very next day you approach the same bank and you ask them for past 10-year bank statements, which you can't expect the same span as you get your 3 months bank statements, because all your data will be moved to the back end from which they will start generating some reports. Is very much crucial for organization development. In this process, storing your data, transferring your data and processing your data, there are several drawbacks. Let us just discuss what are all those drawbacks and why we need an alternative and why that alternative should be Hadoop. Let me just talk about data storage and processing literature survey. We know the data is too precious. We classified the data as people's data and machines data. When I talk about people's data, we the people usually generated some data from the social networking sites like e-commerce, online shopping, online reservations and banking sectors. We usually generated some data. And we the people generally uploading images, videos, likes, comments, tweets, shares, whatnot, everything. And all the stuff we generating the data. And machines also generated your data like RFID readers, sensors, GPS traces, satellite communication and your system log files. These are all comes under the machines data. Where the challenges initially for the organizations, Google, Yahoo, Amazon, Twitter, Facebook, all these are the guys who usually with large magnitude of data. But now this is the problem to almost 90% of the organizations. They are just suffering from large magnitude of data. They don't know how to handle that. Not only simple magnitude, there are several other factors with your data. At last, I passed a bold statement stating that existing methodologies were becoming inadequate to process such large data sets. Let me just share. Please mute yourself. Yeah, I muted you. If you have any query, we'll just type it on chat window. Right. Let me just start the journey, the data storage perspective. When I talk about the data storage, the first and foremost word that will strike away your mind is nothing but RDBMS, which has been ruling the industry from the past 2 decades, but where RDBMS have several drawbacks. Some of them are like there is a storage saturation limit, where RDBMS can't hold or perform well with a large magnitude of data. We can't store terabytes of data. And schema on right, whenever you want to upload the data in RDBMS initially, you need to define the schema. And if you get any new field other than you defined, you can't store that obviously. So you need to know what sort of data you will get in future. and if you get anything other than that, you can't store that. So that is one of the drawback. And above all, there is no support for unstructured data, which is the most sounding stuff. Let me just share what exactly unstructured data is. The data in which you can't design any schema comes under the unstructured data, where XML files, HTML files, log files, images, audio files, video files comes under the unstructured data. But it is quite unfortunate, about 90% of the data which is being generated unstructured data. And well, your RDBMS fails at this perspective. This is just regarding the data storage in RDBMS, but when we talk about the physical storage of disks, the largest hard disk so for availability is 24 terabyte. We usually purchase the SAN storage, in which we have been storing the data by using FC disks, but the latest enhancement is SSDs, solid state disks. So the word SAN, it is too expensive because we use switches in the SAN. It's also expensive, and FC cables for expansion is also expensive. Not only storing your data, usually you need to provide redundancy for your data also by using RAID levels, which are also expensive. So finally, on an average, you can't store unstructured data, number one, and number two, it is too expensive. These two are the most sounding drawbacks. Let me just share what about the data processing challenges. And here, when I talk about the data processing, obviously after storing the data in RDBMS environment, and usually we are just transferring this data from storage area to processing area. Just a minute, guys, I got to go. Sorry. Yeah. So whenever, if you want to process your data, must and should you need to transfer the data from storage area to processing area by using third-party plugins like Informatica Golden Gates. Informatica Golden Gates, like this type of third-party plugins. And you are just transfer the data from storage area to processing area. In that processing area, we are using Teradata, like Netezza type of technologies. When we just talk about Teradata is very good approach to process your data and to store large magnitude of data. But Teradata, it has drawback. Though Teradata can process the data in parallel way, the block size of the Teradata is only 16 KB, which is very less. And above all, it will not work with normal hardware. They will require high-end hardware like a blade servers and Spark processors to work on. And I need to talk about the RAM. It's also become a high-end hardware. The largest RAM so far available in 128 GB. In the data storage, we are already discussed, it's not support for unstructured data and it is too expensive. And the same expensive came into the picture in the data processing perspective also. Because we need high-end hardware. It is too expensive. And it can't support unstructured data as well. And let me just talk about network constraints, because the word network itself indicates the several drawbacks, and currently we are using FC cables for transferring your data, which we could acquire a transfer at 16 GB per second at most. I think 16 GB per second transfer rate is not a simple transfer rate, it's huge transfer rate. Though your network could able 16 GB per second at largest speed, but your disk can't read that much faster. And at this perspective, I need to talk about a simple word is called a disk seek time. As disk seek time, I think you know disk seek time. And though your network could able to transfer the data at this most 16 GB per second, but the disk speed hardly at 250 to 500 Mbps. So obviously there will be a bottleneck problem. And we usually use a Linux or Unix flavor for storing the data. Let us consider I have Linux operating system. So obviously my Linux operating system block size is 8 KB. Let us consider I have 64 MB data. 64 MB size data. If I want to store 64 MB data into my Linux operating system, so internally 64 MB data consumes 8000 blocks. Internally 64 MB data consumes 8000 blocks. When in order to retrieve same 64 MB data, a disk head need to be moved 8000 times from one block to another block. The time taken by a disk head move from one block to another block in order to retrieve the data back is nothing but disk seek time. And after all retrieving 64 MB data, my disk head need to move 8000 times. After all retrieving 64 MB, not in gigabits, not in terabytes. If you want to retrieve your 64 MB data, your disk head rotate 8000 times. What about terabytes? What about petabytes of data? So we need an alternate. Till this moment I didn't spell any word about Hadoop. I'm just raising the drawbacks of existing methodologies. Till this moment I'm just raising the drawbacks of storage and processing and network constraints of existing methodologies. Here I have total 4 drawbacks. I'm just raising 4 drawbacks. Number 1, my existing storage and processing methodologies, they can't support unstructured data. Number 2, the storage and processing hardware is too expensive as well methodologies. Number 3, I have bottleneck problem. And number 4, disk seek time. Right. So this is just diagrammatic representation what we discussed till this moment. See, my RDBMS can't support unstructured data. Number 1. Number 2, the hardware is too expensive and the technology also here is expensive. This is number 2. Number 3, we got a bottleneck problem. Why? Because we are transferring the petabytes and terabytes of data from storage area to processing area. At this time your transfer rate is 3.6 Gbps, but your disk speed is 250 to 500 Mbps. So obviously you got a bottleneck problem. Number 3. And number 4, disk seek time. Your block size is 8 KB, so your disk head retrieve your data a little bit latency. So obviously you got disk seek time. That is the 4th drawback. So for all these we need an alternative. That alternative should be support unstructured data. That alternative should be works on cheap commodity hardware. That alternative should be works on traditional database. That alternative should be overcome the drawback of bottleneck problem. That alternative should be overcome the disk seek time. So that is one and only Hadoop. That is one and only Hadoop. Right. So till this moment I didn't spell any word about Hadoop again. And here the main reason why how much focusing on data much here is, I think you're the guys heard about these words. IDC, International Data Corporation. Basically, it's not very easy to measure the total volume of data stored electronically. The work of IDC, International Data Corporation, work is just analyze every year. Here it analyzes the digital data in every year. See, according to IDC, the world's data is digital data. In 2006, it is 0.18 zettabytes. Zettabytes. I just gave the magnitude here. 1024 gigabits equals to 1 terabyte. 1024 terabyte equals to 1 petabyte. 1024 petabyte equals to 1 exabyte. 1024 exabyte equals to 1 zettabyte. 1024 zettabytes equals to 1 yettabyte. So in 2006 your world's data is 0.18 zettabytes. In 2011 the world's data is 1.8 zettabytes. If you observe that in the span of 5 years, it increases 10 times. I think 10 times is not a simple figure. It increases 10 times. I think 10 times is not a simple figure, right? So, and they're expecting 2020, within 6 years, they're expecting 40 zettabytes of data. The world's data reaches to 40 zettabytes. It would reach. Where this data comes from? What are the resources? Day by day the technology growth is increased. Millions of apps are there. Millions of mobile phones. Millions of people, they are using Facebook. They're uploading images, videos, whatnot. Everything. Every day. And LinkedIn, WhatsApp, even your mobile phones. If you call to someone, it's just registered call log. It's just some data. So sensors, GPS traces, your shopping mall, online shopping reservation systems, and your barcode readers, traffic signals, whatnot. Each and every electronic device generates some data, whether it is bytes, MBs, gigabits, whatever it is. So each and every electronic device generates some data. So day by day the technology growth is increased, and millions of electronic devices are working per day. So obviously you got a lot of data. And here your hard disk capacity, the world's largest hard disk size, only in terabytes. Only in terabytes. But your data generated in zettabytes. So how many hard disks, how many terabytes space we need to store 40 zettabytes of data? Approximately it is 4 into 10 power 10 terabytes of space we need to store 40 zettabytes of data. Not only storing, you need to create the backup for that, right? Redundancy. So obviously again you need to purchase 4 into 10 power 10 space. It's not a small issue. It's too expensive. So we need an alternative. We need an alternative. That is one and only Hadoop. Right. And 80% of the data it is generating unstructured data, and I classified the data as structured, unstructured, and semi-structured. When we talk about structured data, the best example, you can process this data by using SQL. You can design a particular schema like ID, name, salary, like that. It is structured data. You can design one particular structure on that data. Then you can call it structured data. And unstructured data, when we talk about unstructured data, the best example, your video file, audio file, images, XML files, HTML files. See, I just gave you one video file. You can't design any schema on that. If I give you employee details, ID, name, salary, you can design, create table name, and you can design the schema, right? And semi-structured data, it is 50% structured, 50% unstructured. The best example, your email. If you observe that, you have two CC, BCC, text body and some other panel. When we talk about two CC, BCC, these three fields are structured and rest of the text body and some other panel, it is unstructured. Why? Because, why I classified that one like that as, see, when we talk about two CC, BCC, in these three fields, it accepts only some structured data like some xyz@gmail.com, Kiran@gmail.com, Raghu@gmail.com, like that. If you enter any number or any character without that format, format, it doesn't take. It shows error. So it follows some structure. When we talk about text body and other panel, in that text body you can enter any sort of data. It will support. It will support whether it is number, character, mail format, or else symbol, whatever it is. And even you can upload the 25 MB of file, whether it is video, audio, whatever it is, it will support 25 MB unstructured data. So your email, we can take that one as semi-structured data, 50% structured and 50% unstructured, right? And big data, this is hot cake in the market. And big data, this is not a technical term, this is just a general term, sorry. This is not a technical term, not at all technical term, this is just normal general term. Any data having several characteristics could be spelled as a big data. Let us talk about what are all those characteristics processed by data in order to spell as big data. The best example before rushing into topics, just I'll give you best example. I'm asking you how much data in your hard disk. You said I have 1 terabyte of movies. Fine. So here you spelled 1 terabyte movies. So 1 terabyte, that is volume. Movies. So obviously whatever it is, whether it is structured, unstructured, semi-structured. So movies, it is unstructured. That is unstructured format. Obviously your movies have the transfer rate, is the rate at which you need to processing that data, whatever it is. Transfer rate, obviously each and every data maintains some transfer rate. So your data has size, some particular format and transfer rate. Then you can call big data simply. But the size is more, must ensure it is not in MBs, not in KBs. You were not in GBs. If your data size is too huge, then you can call big data. So simply call big data. Volume, your movie size is 1 terabyte, and variety, whether it is structured, semi-structured or unstructured, whatever it is, whether it is movies, office data or mail data, whatever it is, some variety. And velocity, obviously each and every data has some transfer rate. So if your data maintains these three characteristics, then you can call big data simply. So we need to store this big data, but your existing methodologies can't support. Why? Because your RDBMS can't hold petabytes of information, or in processing scenario also terabyte. It can't hold petabytes and zettabytes of information. Unstructured data, zettabytes of unstructured data. So we need an alternative. That alternative should be overcome all these drawbacks, right? So till this moment I didn't spell any word about Hadoop. I'm just raising the drawbacks of existing methodologies, and I'm just discussing about IDC as well, our data classification, structured, unstructured and semi-structured. I'm just discussing about big data. I'm just discussed about big data. That's it. Now we need an alternative for all these drawbacks, simply for supporting the big data, right? So that is only Hadoop. Now we'll discuss about Hadoop. Hadoop, this is not a technical term, not at all technical term. This is the pet name, is the funny story. Java name, it comes from Java Island, same as Hadoop, this is the pet name, right? And see, Hadoop, this is not an operating system, this is a framework, this is not any desktop application. Hadoop is a framework. In Hadoop we have two components, core components. We are called core components, HDFS and MapReduce. Two core components. One is for storage and one is for processing. But if you observe that in existing methodologies, this is for storage. Your storage in one place and processing in another place. But here both are in single place. Storage in same place and processing also same place, same machine. Storage also same machine and processing also in same machine, right? And here Hadoop is a framework. Under the Hadoop we have two core components, HDFS and MapReduce. HDFS, Hadoop Distributed File System. I think distributed file system is not new, it is old. Hadoop Distributed File System is new. Why? Because Hadoop Distributed File System block size is 64 MB. As per our previous example, you have 64 MB data, you are loaded that 64 MB data into Linux environment. So here your Linux environment block size is 8 KB. So your 64 MB data internally it consumes 8000 blocks. Same 64 MB data, see here the drawback is if you want to retrieve the data from your Linux environment, your disk head need to rotate 8000 times, right? This is one of the, it's not a drawback, it's just little bit latency. We got latency, data fetching latency. Same 64 MB data if you store in HDFS, it will store as single block. Why? Because default block size is 64 MB. It is configurable. Even you can configure 128 MB, 256, 512 MB block size. Say if you wanna store 64 MB data into your HDFS, it will store as a single block. If you wanna retrieve same 64 MB block, your disk head rotate only single time. Only single time. So you can get your data very fast. You can't get disk seek time here. You can reduce that disk seek time. So obviously in our 4 drawbacks, one drawback is down. And MapReduce. So HDFS, this is only for storage. We'll discuss in deep later. And MapReduce, this is for processing. So here you can design MapReduce code. So as per your requirement, you can design your MapReduce code with the help of Java, CPP, Python, Perl, Ruby, any one of the language. Any one of the language you can design a MapReduce program and just submit that code from design area to storage area. That means towards data. Just submit the code towards data. But in existing methodologies, you are transferring the data from storage area to processing area. You are completely moved the data from storage area to processing area, whether it is terabytes, petabytes, whatever it is. If you want to process this, must and should you need to transfer the data from storage area to processing area. So here we got bottleneck problem. Why? Because over the network we are transferred petabytes and terabytes of data. But here over the network, few KBs and MBs of program. Maximum I think your code is in MBs. That's it. So your MBs of code transfer over the network towards the data. It's not an issue, right, over the network. So obviously you can't get any bottleneck problem here. Your data is same in storage place. You will just transfer the code. That's it. So obviously the second drawback, bottleneck problem also overcome. And Hadoop process your data in massive parallel manner. Your MapReduce process your data in massive parallel manner, not a simple parallel manner. We will discuss about this in deep. And Hadoop can make storage and processing at one hub. And this is IBM declaration. This is not my declaration. IBM, they are processed 1 terabyte unstructured data by using RDBMS. It consumes 28 hours of time. Same 1 TB unstructured data, they are processed with Teradata technology. It consumes 7 hours of time. Same 1 TB unstructured data, they are processed by using Hadoop with 180 node cluster. I think you know node means machine and cluster is group of machines. So they are processed 1 terabyte unstructured data on 180 node cluster. It consumes 3 minutes 45 seconds. Same 1 TB unstructured data, they are processed by using the latest enhancement of Hadoop, that is Yarn architecture. Yarn architecture. It consumes 1 minute 14 seconds. See how your Hadoop process your data. And Hadoop, its process, it works on completely cheap commodity hardware. No need to purchase high-end hardware. So that's why, as per your, we are configuring Hadoop cluster in your machine from day 4 or 5. After basic discussion, we are configuring Hadoop cluster. The minimum requirement for Hadoop is in practice oriented, not in production. In practice oriented, you need minimum 1 GB RAM and 20 GB hard disk just for practicing oriented. If you want to work with production, the configuration is different. There is a little bit heavy, like 32 GB RAMs, 64 GB RAMs, like that. We will discuss about that in detail later. And this is just internal architecture of your Hadoop. See, as per our previous slide, we got Hadoop have 2 core components, and one is HDFS and another one is MapReduce, simply called computation part. So here, just for basics, I just configure 640 MB. I need to load 640 MB data. MB is too small for Hadoop. See, just for example, just for ease, I just take in 640 MB data. So if I want to store 640 MB data into my cluster, so by default your HDFS block size is 64 MB. So my 640 MB data split it as small pieces and scattered across the cluster. So 2 blocks are here, 2 blocks are here, and 2 blocks are here, and rest of the 4 blocks in different machines. Here there is no space, so just, and here, as per your requirement, you are just designing a simple MapReduce program by the help of any one of the language, and just submit that code to all machines parallel way. And MapReduce process your data in massive parallel manner. So you are submitting your code to all machines in parallel manner. So each and every machine, by using your code, it will process your data. One machine processing is not depends on another one. And I spelled your MapReduce process your data in massive parallel manner, not a simple parallel manner. It processes your data in massive parallel manner. Massive parallel manner. That means again internally your code submits parallel to each and every block. So here this block process itself and this block process itself by JVMs, Java Virtual Machines. Each and every block process itself. and generates data. Final output. Right. So your MapReduce only for processing like this. Your HDFS, this is only for storage. In Hadoop always we send the code towards the data. Right? And Hadoop, it is very easy to move computation rather than moving data. And Hadoop, it's massive paralleling, parallel processing for use. And it is very easy to deal with small data rather than data sets. And Hadoop is completely runs on cheap commodity hardware. You don't need to purchase high-end hardware like blade servers and Spark processors. And most of the people, they are asking me this question, so that's why I just specified here. Why can't we use databases with lots of disks to do large-scale batch analysis? Why is MapReduce needed? In MapReduce mechanism, we are just transfer the code towards the data. So we can't get any disk seek time as well, we can't get any bottleneck problem. And the block size of 64 MB we are maintaining for HDFS. So your MapReduce can work with on it. And MapReduce supports any sort of data, whether it is structured, semi-structured and unstructured, whatever it is. And till this moment we are just discussing about discussed about storage and processing. Storage for HDFS and processing for MapReduce in Hadoop. We didn't discuss it about redundancy, means backup. So here for that replication we have. So by default we have 3 replication factor. That means whatever you upload the data, that data split it as 3 pieces. That means maintained as 3 copies. That means if you want to upload 1 terabyte of data to our Hadoop cluster, by default it uses 3 replication factor. So your 1 terabyte data copied into Hadoop cluster as 3 copies. That means 3 terabyte of data. Even you can configure 1 replication, 2 replication, 3, 4, 5, up to 512 replications Hadoop will support. And same as you need to increase your hardware. Right. So your MapReduce can work on all these constraints. And you heard about these words: Hive, Pig, Scoop, Flow, Muzi, all these things. All these tools, ecosystem components are supporting tools for Hadoop. Yeah, and this is the latest enhancement of MapReduce version 2. See, I'm not well versed with coding background. I'm well versed with SQL background. Yeah, you can go through Hive. So this is one of the ecosystem component. It will support Hadoop HDFS. I don't know any coding background. I don't know any SQL background. I'm well versed with scripting background. No problem, you can go through. Pick. I don't know anything. I'm well versed with Linux, Unix commands. Yeah. You can go through Hadoop administrator. In Hadoop we have total 3 positions. Admin, developer, architect. For a development you need little bit basics on, you need the knowledge on coding. And for admin scenario you need Linux. If you want to go through architect, must and should you need to complete grip. You need complete grip on each and every ecosystem component and everything, every technology, right? In our training we have discussed each and everything: Pig, Hive, HBase, Scoop, all these things, as well cluster configurations. And you heard about these distributions: Intel Hadoop. Intel provides their own Hadoop, it is Intel Hadoop. And Cloudera distribution. And Mapper, it provides R. And Teradata, the distribution of Teradata is called Astrodata. And EMC Square, it provides Hadoop, is called Greenplum. And Hortonworks is also one. And IBM provides Big Insights. And Amazon provides EC2. And Microsoft, it provides HD Insights. And for all these distributions, the further is Apache. He is open source. anyone can download and anyone can use this. Even you can download and you can edit the source code, and based on that the rest of the distributions they are created. The major variation between Apache and these distributions are nothing. The major thing is just user interface, UI. So each and every distribution maintain their own UI, but the functionality both are same. HDFS and MapReduce, same functionality, but the UI is different. That's it. And here you need to purchase some licenses, but here you don't need to purchase any licenses. And in our training we are go through this one. Why? Because this is the basic one for all distributions as well. Cloudera, this is the topmost organization in all these. The services and everything is better in Cloudera, and the certification value also, it is too high for Cloudera. It is $295. $295, and I'll show my certificate and see. This Cloudera, this is the topmost organization. So in our training we are configuring Hadoop practice environment as well, production level environment if you have multiple physical machines in your home or else in your office. And Cloudera also we are configuring single node as well, multi-node. That means a practice level as well, production level, both the distributions. Okay. And these are the companies they are using currently. They are using Hadoop: New York Stock Exchange, Facebook, American Airlines, Walmart, Bank of America, Mac, Big Direct TV. I think you have a lot of openings on Direct TV. You can check it out. And Mac and Wells Fargo. So all these are maintained currently Hadoop, and according to Gartner's report, at the end of 2015, 80% of the organizations, they are completely migrated from existing methodologies to big data technologies like Hadoop, Hive, Peak, like these ecosystems. So completely it's migrated from existing methodologies to Hadoop, simply. Right. So till this moment in this presentation I'm just discussed about the rising the drawbacks and few concepts about IDC and structure and semi-structure and big data, and here about Hadoop and about this. So till this moment is it clear? If you have any queries you can fire me with your queries. I just unmuted you. Yeah. Kiran and Raghu. If you have any queries,